Planet formation begins in the same molecular cloud where a star is formed. The rotation of the cloud causes the formation of a protoplanetary disk around the star. In the beginning, this disk is made of tiny grains of dust. Astronomers believe that these grains stick together when they collide, creating bigger and bigger objects until a planetary system becomes visible. This process takes millions of years and is not yet completely understood. Astronomers are interested in following this process step by step, starting from the earliest phases of protoplanetary disks. But how can we observe such tiny grains of dust from so far away with a telescope? Let's ask an astronomer.
So how small are these dust grains initially?
Dust grains are far too small to be seen, even with the biggest and most powerful telescope. They are as small as a red blood cell, or to make another comparison, they are 50 to 100 times smaller than the diameter of a human hair.
So if they're so small, how can you measure them?
Once again, as it always happens in astronomy, the information is carried by the light. The light, in this case, emitted by the dust grain. Because even if they are tiny, dust grains are still much bigger than the optical wavelength, and for this reason, they act as bricks that block starlight. Then they emit at longer wavelengths, mainly in the far infrared or millimeter range.
So what is the typical wavelength?
The typical wavelength where most of the emission is observed depends on the grain size, and is roughly 2 times pi times r, where r is the particle radius. So the greater the size, the greater the flux we can measure at long wavelengths. And in this way, using a plot flux versus wavelength, astronomers can infer information about the dust size and see if there's a process of dust growth.
So once a new planet is formed, is this more easily observable than these dust grains?
But not so easily as one could expect, because exoplanets are very far away compared to planets in our solar system, and then they don't emit light like stars. Nevertheless, there are several indirect methods to detect them, and it's amazing that after only 18 years since the first planet was discovered, more than 700 new exoplanets have been found, and about 3,400 candidates are waiting to be confirmed.